Thanks, Carl. Lewis Bradford have been privileged to contribute to the recovery of Christchurch over the last decade. And tonight I'm going to speak about my experiences as a structural engineer, living in a city which has been devastated by earthquakes and is slowly coming out the other side. I'm going to focus on 5 particular buildings, both completed and ongoing, where we have played a role. And all of these buildings were at risk of being demolished following the earthquake due to a range of factors. And we've managed to work towards keeping them. When the majority of the built environment of a city is lost, what can structural engineers do to help bring life back to a CBD? I will also discuss the evolution and engineering design of some large-scale public artworks in Christchurch. And then finally, in late 2019, back when we could still fly on aeroplanes, Lewis Bradford were humbled to receive the Institution of Structural Engineers Award for Structures in Extreme Conditions for the design of Turanga, the new library. I'll briefly outline the performance-based design of this building. Let's first go back to the night of September the 3rd, 2010. I was 12 weeks pregnant with my 3rd child, and we had a teething 11-month-old baby who had woken up each hour that night. At 4:35 a.m, we were awoken again by an extremely loud and violent earthquake. It was so strong that we did not attempt to get out of bed, and it was as if a freight train was actually coming through the bedroom. It was magnitude 7.1 and centred 40 kilometres west of Christchurch at a shallow depth of only 10 kilometres. The Darfield earthquake was the largest earthquake occurring near a populated area in New Zealand since 1931. And the freight train vibe that we got was due to where the fault line rupture ended. So you can see on the slide, the red dot is where our house is, and the red line is the fault rupture. When it stopped, my husband, fellow structural engineer, who some of you may know, Craig, his first words to me were, "There will be buildings down." As it turned out, the city fared well, and somehow, despite numerous near misses, there were no fatalities. I worked on secondment for the Selwyn District Council. I was responsible for the rapid safety assessment of a variety of buildings, including schools, community halls, pubs, shops, industrial buildings, a youth jail, and numerous residential properties, including this house, which was on Telegraph Road. It had the main fault rupture running through the middle of it. You can see it there. It went in the front door and out the back door. And it did pretty well. Over the following 5 months, engineers were extremely busy, including some of you folk from up north, inspecting buildings and reporting on damaged commercial and residential buildings. The CBD had a large number of 2 to 5 storey unreinforced masonry buildings occupied by offices, retail and hospitality tenancies, only some of which had been seismically secured. A handful were demolished, some were cordoned off, and some were unfortunately still occupied. I wrote a letter to the editor of the press in October 2010, encouraging people to seismically strengthen unreinforced masonry buildings, to secure their furniture and to get rid of their chimneys, getting ready for future earthquakes. There was a growing sense of unease in the engineering fraternity as the aftershocks started occurring well away from the main fault line, including most significantly the magnitude 4.9 Boxing Day 2010 aftershock, which was centred under the centre of Christchurch. At 12:51 p.m. on February the 22nd, 2011, Christchurch suffered an extremely violent magnitude 6.2 earthquake that was only 5 kilometres in depth and very near the CBD. It resulted in the tragic loss of 185 lives. Nearly 80% of the buildings in the CBD were eventually demolished. Some because they were uneconomic to repair, others due to generous insurance policies, and some were compulsorily acquired by central government and demolished to suit the new Christchurch rebuild blueprint. The seismic design standards were primarily focused on life safety at ultimate limit state, and rightly so. Ductility in structures dissipates seismic energy, however, it also translates to damage. With two tragic exceptions, nearly all of the modern buildings in Christchurch did what they were designed to do. In the February earthquake, they preserved life safety. Unfortunately, many structures that needed to be demolished due to the extent of damage that they suffered. The benefits of being able to save an earthquake damaged building are wide-ranging. It makes economic sense, it saves time, and it's obviously got heritage and environmental benefits. That's my husband Craig there on the sand boil. I'm going to talk about 5 buildings that were not demolished, but easily could have been. The first of which is Ronald McDonald House. It's a home away from home for families with sick children that are being treated down the road at Christchurch Hospital. I was the design engineer for the building in 2002, and it was extended in 2010. It is a concrete structure, so it has concrete shear walls, concrete floors, concrete gravity frames, and it has a basement that is 2 metres in the ground. It has 3 suspended levels, and the basement slab was designed for seasonal fluctuation of the water table, with standpipes designed so that if the water table rose slowly, the basement would be flooded and the buoyancy pressures would be reacted by the water pushing down on the slab. Following the September earthquake, the building sustained only cosmetic damage and was able to continue operation. The February 22nd earthquake was shallow, and although it was relatively short in duration, the shaking was extremely violent and there was widespread liquefaction across Canterbury. The water table effectively rose to ground level instantaneously. When Craig met with the head trustee of Ronald McDonald House and the original site foreman to inspect the building after the February earthquake, the builder was in tears. He thought that the building needed to be demolished because the perimeter had settled. Craig had a hunch that what had actually happened was hydraulic upheaval due to the rapid water table rise. This was confirmed by a level survey. The basement slab and internal gravity columns had actually been pushed upwards 80 millimetres. Three of our staff were in the basement of Ronald McDonald House carrying out an investigation on June the 13th when there was a large aftershock. This photo was taken during that aftershock. You can see Tim Shannon running as fast as his little legs will carry him, carrying his clipboard. And you can also see that there's evidence here of punching shear failure from the February earthquake. So water was coming up through the crack that Craig had just had his finger in moments beforehand. So the 300 millimetre thick basement slab had actually punched up. So Ronald McDonald House, the interesting thing about them is that they were self-insured internationally. So they were highly motivated to get the building fixed so that it could be up and running as soon as possible. Commencing in December 2011, the repair work began on site. We were still experiencing aftershocks very frequently at this stage. So particular care needed to be given to the temporary works design. What was done was that the internal gravity frames were propped and the basement slab and the columns were demolished. The internal gravity frames were then gently lowered back down until when people went upstairs they could open and shut the doors again, and a level survey showed that it was level again. Tension anchors were installed in the basement so that the slab would be held down, and a replacement slab was cast along with new columns in the basement. And the success of this project really was that it was completed in only 10 months, and it saved a significant amount of money in terms of not having to rebuild it. And the great thing was that the families of the sick children could get back in there a year after the earthquake. Now, you may recognise this hotel from the news today. It's where the Chiefs stayed on the weekend after they lost to the Crusaders. It's a 14-storey hotel, and it comprises of a basement car park, 3 levels of retail and back of house, and 11 levels of a 4-star hotel on top. It was constructed between 2008 and 2010 on a challenging site, and at the time of the February earthquake, it was the newest hotel in Christchurch. The construction consists of in situ concrete basement, including tension screw piles, a combination of precast and in situ primary shear walls. It has a structural steel gravity frame and tray deck flooring, and it also has precast cladding panels. This is my sophisticated overview of the seismic structure. So we've got a large podium for the bottom 4 stories, and then on top a tower, and it has 2 shear walls in each direction. The walls were carefully designed to form plastic hinges about 500 millimetres above the level 4 podium level, so that the level 4 diaphragm wasn't affected. And it was detailed really carefully and conservatively using requirements for ductility level 6, but only with ductility level 3 loads. And the plastic hinge zones have grade 300 vertical reinforcing in them. Everything else was then designed for the overstrength actions of the plastic hinge zones. And this is what we got on February the 22nd. That's what you call a classic plastic hinge zone, and it formed on the southern shear wall. The northern shear wall was a little bit stiffer because it was a coupled structural wall, so it only suffered minor hairline cracks, and the resulting torsion caused some minor hairline cracking in the 2 north-south walls. You can see here that the crack pattern was significantly from west to east, and an observation that we made was that it was from the initial nasty pulse of the earthquake. So you'll see that in Colombo Street and Manchester Street, a lot of the damage was on the west side of the road as the facades fell into the street with that initial pulse. The 125mm thick precast cladding panels suffered spalling damage due to the shaking, causing deflections that were in excess of the design code level event. And the original cladding movement joints had, in some instances, inadvertently been solid dry packed, and some temporary steel brackets had been left in place, which exacerbated the damage. So the cladding panels were progressively removed and replaced with top-hung floor-to-floor facade panels that incorporated enhanced movement joints at the base. The movement joints were designed for the full current code level requirements, including the post-earthquake increase in loads. Following extensive analysis and testing, the yielded regions of the southern shear wall plastic hinge zone were able to be progressively demolished and replaced. The yielded regions measured up to 2 metres long, and the cracking was well distributed in a flexural pattern, with most cracks being less than 0.5 millimetres in width. Now, as you recall, this was done during the aftershock sequence, so the staging of the work had to be really carefully managed to ensure that adequate temporary strength was provided at all times, and that included infilling some other windows to always have sufficient strength at any stage of the construction. The first step was actually replacing the section of wall 1 metre away from the end of the walls to beef that up in terms of its ductility and confinement, and then the yielded end regions were replaced. We were really lucky because we had Professor Nigel Priestley review the shear wall repair, and he called on his extensive experience testing over 300 walls in his career and displacement-based design on the back of an envelope to determine that the repair work that we were carrying out was sufficiently conservative. And the hotel reopened in August 2013, which coincided with the red zone in the city being opened up. The next building I'm going to talk about is the Forsyth Bar building, which was constructed in the late 1980s and named Robert Jones Tower. At the time, it was the second tallest structure in Christchurch in the South Island, actually, at 18 stories tall. It comprises of in situ concrete reinforced concrete frames, moment resisting frames in each direction, and a concrete ribbon infill floor system. And it's founded on a 1.6 metre deep raft. The lower 4 stories form a podium that was originally car parking and retail space. And when I was at university, my friend from Wellington used to call it Christchurch's CBD, or Central Business Building, since we weren't quite as metropolitan as Wellington. After 9/11, some of the tenants in the building stashed some climbing gear under their desks in case anything ever happened. In the February 22nd earthquake, you'll recall that the precast concrete stairs collapsed on one side up to level 13 and on the other up to level 15. The stair units were code compliant, and they'd been built floor to floor as single precast units with a mid-height landing, and they're tied in at the top and they were sliding at the base. It was later deduced that the stair collapse was caused by the seismic joints at the base of the stairs not having sufficient movement, clear space, either because of the construction debris infilling the gaps or due to inadequate construction tolerances. A number of the stair units were put into axial compression as the tower frame displaced, and then likely suffered bending failure, then shortened and fell off their seating at the base, pivoting down and fracturing the top connection. This is a picture of that fractured top connection. And miraculously, given it was lunchtime at the time of the earthquake, it transpired that there was no one in the stairwell at the time. In what became one of the iconic images of the day, some of the upper level tenants decided to use their emergency supplies to abseil out of the building and onto the podium. The first to go was Jay Moss, who now has the nickname medium-sized man because that's what they called out when they were looking for someone to volunteer. Lewis Bradford were engaged in 2014 when the building was purchased as is, where is, in its earthquake damaged state. And the tower was extensively modelled and analysed, and physical investigations were carried out with testing done on concrete and reinforcing samples. And it's a testament to the original design by Holmes and construction by Fletchers, I think, that the tower frame was in really good condition and had performed really well. And it was also helpful for us that the natural period of translation for the tower appears to have coincided with a trough in the seismic hazard demands for both the 2010 and 2011 earthquake. So the building was to be converted to a hotel. So the podium was partially demolished and reconstructed to suit the removal of the car parking ramps. And a tricky part of our work was to redesign the stair, which was peer reviewed by about 25 million different engineering companies. Essentially, it's got a lot more sliding capacity at the base. The lower landings were extended, and it's now got the capacity to slide 500 millimeters, which is equivalent to the maximum credible earthquake event. Then there's debonded starters at the top, and there's been additional structural steel put in at the mid-height landing. Another challenge was actually building the stair, because it's not often that you need to construct a stair in a 18-storey tall open shaft. The refurbishment involved largely minor repairs to the actual tower. So some sections of the floor diaphragm, particularly around the moment frame columns, were damaged due to minor frame elongation of those perimeter frames. The floor reinforcing mesh was investigated and tested, and it was found not to have fractured, but it was enhanced with sections of greater reinforcing, and extra strut and tie members were added for additional diaphragm performance in the future. Extensive crack injection was used to the floors, beams and columns. And some columns were enhanced with FRP wrapping. The critical southwest and northeast columns were extended with in situ, with reinforced concrete in situ sections, because it was established that they had suffered some tension yielding over some levels. In 2017, the Crown Plaza Hotel opened with 204 rooms, and it has a new 19th story penthouse. And it's once again the second tallest structure in the South Island, since a couple of other ones have since been demolished. So thirdly, I'm going to talk about 92 Litchfield Street, which is a heritage building, and it was built in 1893, designed by architects in Melbourne and built for a branch of warehousemen called Sargood, Son and Ewan. It traded continuously for 80 years until 1973, when it was subsequently occupied by a clothing manufacturer. Lewis Bradford were engaged in 2003 to carry out seismic strengthening on the building, and I was responsible for the detailed design work and construction monitoring of the project. When we first looked at the building, it would have been good for about 10% code in the west-east direction, because it essentially had no structure in that direction. So it's 50 metres long and it's 18 metres wide, and it's got unreinforced masonry walls to the perimeter, and it's got a timber framed floor, first floor and second floor, with a floor to floor height of about 5 metres. So it's a beautiful old building, and a attic apartment was added as part of this refurbishment in 2004. Essentially what we did was add some west-east walls, which you can see up and down the page of that slide, and we tied it all together, tied all the heavy parts together. So there was extensive structural steelwork put in at roof level, and plywood floor diaphragms were put in at floor levels, and reinforced concrete walls in each direction, some of which were skin walls and some were just in situ internal walls. It's before the days of decent digital photography, sorry, so that's the only photos I could find of during construction monitoring. So at the time, the requirements were to strengthen the building to 1/3 full code, but instead we convinced the owner to go to 2/3 full code, which in the February earthquake ultimately saved lives. You can see that that photo was taken in February 2011. It's the building on the right hand side there, and those bricks on the ground are from the neighbouring building, the ministry. So nearly all of the other unreinforced masonry buildings of this vintage in Christchurch were not able to be salvaged. And this is what happens if a building goes through thousands of aftershocks, many significant, before you can get in and repair it. So in December 2011, we had a partial collapse of the western facade, and at the time, the whole of the central city was locked out, so there were no people around. So we've been fortunate enough to have another chance at strengthening the building. It's been brought up to 80% MBS, which is of new code, so that incorporates an extra 36% increase from 2011. And the new strengthening work, which has been designed and consented, it's yet to actually be done, but it involves a whole lot of new elements. So more concrete walls, more foundations, and more diaphragm elements, new steelwork at roof level, and most significantly, to hold up the front facade, we've introduced a structural steel truss at the ceiling level of each level with anchor bars right through the northern facade, which already has a 200 thick skin wall on the inside of it. And we're hoping that this will get underway soon. It's currently on the Christchurch's Dirty 30 list of buildings which are sitting with containers in front of them, unfortunately. Moving on to a building that is getting fixed, the Christchurch Cathedral is our most recognised symbol of Christchurch. And in the February 22nd earthquake, you will recall that the spire collapsed and the top of the tower. Fortunately, no one was hurt. In 2018, I was approached about the prospect of becoming a director on the joint venture company tasked with reinstating the building. I jumped at this chance, and it's been a once-in-a-lifetime opportunity. Other board members include an investment banker, a lawyer, and 2 contractors, and they all have far more governance experience than me, so it's been a steep learning curve. And as an aside, I'd encourage engineers to consider governance roles on special construction projects, because it really is an excellent way to contribute, and we have good technical skills that are quite useful around the board table. The joint venture company has been set up between the Anglican CPT, the Church Property Trustees, and the Reinstatement Trust, which is the fundraising body set up by the government. And our joint venture company had to be set up from scratch. So that included finding offices, setting up banking, accounting systems, getting insurance, employing staff, then engaging consultants. So we have Holmes Consulting doing the structural engineering on the project, and they've had a lot of input from Naylor Love as early contractor involvement, which has been really useful. So the challenges of the project are numerous, as you can imagine. So we've got an ongoing seismic period, we've got an earthquake damaged building, we've got pigeon poo to deal with, asbestos, stagnant water, we've got resource consents to get, and we need to try and preserve as much of the heritage fabric as we can within reason, economically. It's all pretty tricky, but great progress has been made. The stabilisation phase is underway, and so the aim is to get the building up to 1/3 full code before anyone goes inside, so that it would be equivalent to any other building site, which mostly involves frames going up around the outside of the building. Some pieces of permanent strengthening work are going in as part of the stabilisation phase, including this new frame which went in last December for the rose window. And we've got a hoarding, which some people think when they look from down the road, they think we've made really, really good progress and finished the west wall, but you'll see it's just a photograph. And once the strengthening is completed, base isolation is going to be installed. So that's the really tricky part in terms of retrofitting that in. And the benefit of base isolation is to reduce the accelerations down to about 30% of the full code level. The tower will be rebuilt to look pretty much like it did beforehand, with some improvements, including a lift inside, and the bowels will be reconfigured to perform better. And then there's also going to be 2 extra buildings built, one to the north and one to the south. And that's to really bring the cathedral up to modern day standards in terms of functionality. And they have been designed to be contemporary, but to complement the cathedral and not steal the show. So you'll see a sunken courtyard is planned, which is a pretty tricky undertaking, but the aim there is to get as much of the space down below ground level as possible. So it'll look pretty much like it did before, hopefully. So moving on, a decade on from the earthquake sequence, it's easy to forget the significance, the impact it had on everyone who was there. We had 20,000 aftershocks, and I think we've all got post-traumatic stress disorder to some extent or other, whether it's a car alarm that goes off that freaks people out or hearing a helicopter. And whole suburbs of Christchurch were written off, and often that wasn't because the houses were damaged, it was that the infrastructure was too expensive to repair and the government red zoned it. You'll see here a before and after photo around the Avon River. And so it's spooky now when you go to the red zone, because you can still see where different sections were. They're sort of defined by the planting, people's hedges and people's driveways, but there's no buildings left there at all. And coupled with that, you've got many businesses who ended up signing up to 8-year leases out in the suburbs. And so the CBD really became really shut down. So you can see this photograph here is looking southeast down High Street, and that was before the earthquakes. And that photo is looking back up High Street from the other direction, and even some of these buildings have subsequently been demolished. And you can see in that photo the colourful Restart Mall to the top of the slide. This photograph shows the new bus exchange in the foreground, and the eastern side of Manchester Street, you'll see there, has been completely cleared. It was all acquired for the eastern frame by the government, and that's the Crown Plaza standing all by itself now to the top of the page. So whole city blocks have been demolished and used as car parks for 10 years and grassed over. So to try to help bring life back to the city, Lewis Bradford got involved with a bunch of different things, including the Festival of Transitional Architecture from 2013 until its final year in 2018. And we carried out pro bono engineering to help architecture students from New Zealand and Australia with large-scale installations that were put up for just one night only. And the festival encouraged the locals to come back into the CBD. For many of them, it was their first time coming back into the city because they had no other reason, sorry, to come into the city. You'll see in this photograph, what's interesting is that there's no lights on in any of the other buildings. So that was maybe the one building on the corner of High Street in Manchester there, but all the other buildings were not occupied at the time. In 2012, after studying too many of these depressing aerial photographs, I instigated a gap filler project based on a popular board game. This was my original sketch idea of what I was going to do. And this is a photograph of it from a helicopter and a close-up shot. So it was a fun project that got quite a bit of attention for gap filler. And then following on from that project, I wanted to do something that was a little bit more permanent to help. It really struck me that when you looked around the city, the things that stuck out were pieces of public art. And in 2012, I approached Neil Dawson, who you will hopefully recognise as a sculptor who's worked on lots of different projects around New Zealand and Australia, and asked him if he wanted to work on a new sculpture for Christchurch. So I gave him an open brief that he could design whatever he liked, and what happened was he had designed Chalice in the square, and he had never thought it would be possible for the Chalice to still be there but not the cathedral spire. And so he tried to draw the cathedral spire and realised that he couldn't remember what it looked like, and that inspired him to design something based on the cathedral spire. So this was his original concept sketch. This is his first model of the sculpture, which is called Spires. It's supported by 4 posts with cables. And I undertook the seismic, it was more wind design of the sculpture. And we roped in a whole lot of people from the industry to help us build it completely for free for Christchurch. So it's one of our drawings. The sculpture only weighs about 170 kilos and it's constructed out of aluminium. and it was installed in 2014. That's what it looks like now. It's in Latimer Square, just north of the Transitional Cathedral. That's what it looks like at night. And this is what it could look like hanging over the river if it ever got shifted. Some other large-scale works that I've been involved with include Lonnie Hutchinson's Kakahu facade, which is on the new Justice Precinct. So I was engaged by the contractor to help with the specific engineering design of the secondary steel to help support the facade. And it's a bit tricky because it's made up of aluminium feathers. Next, I'll talk about Call Me Snake, which is a 9-metre high steel structure which is clad in plywood. So steel frames which were constructed using a computer model. So the artist gave me a model which I used for analysis, which was then handed on to this shop drawer who handed it on to the builders and the surveyors for putting in the hold down bolts. So it all went in one morning, no problem, which was very exciting. And Judy Miller, the artist, had stickers on each of the jigsaw pieces. And Gregor Krieger's temporary work, which was called Glass Pavilion, was a tricky undertaking in a seismic area. He constructs his own glass bricks and then he puts neon lights inside them. So we had to hide some structure inside his pavilion, which we did with a portal frame, which was up for about 6 weeks over the summer a couple of years ago. This is Tree Houses for Swamp Dwellers by Julia Morrison, and it's a macrocarpa series of planter boxes which have lighting rods poking out the top, and they have ferns that grow up around the fishing poles that we used, and they've since been shifted down by the town hall. In 2016, I helped Scape Public Art instigate a sculpture design competition for school students. So these are some of the winners over the years. We carry out the engineering design for them and help guide the students through the process of seeing their work come to life. It's been a really rewarding project because it's exposing the students to both the world of art but also the world of engineering. And it also helps them see the creative side of engineering. And finally, I'll briefly explain the structural design of Tūranga, which was the winner of the iStruct D Award a couple of years ago. It's a 5-storey building and it's got a total floor area of 10,000 square metres. And it was one of the main anchor projects redefining Christchurch following the earthquakes. And the success of it as a project should be judged against the backdrop of the earthquake sequence. The earthquake sequence really highlighted that while the majority of the buildings in Christchurch achieved the building code requirement of life safety, a great number of them needed to be demolished because they were uneconomic to repair. So we were looking for a better seismic resilience in the design. A key feature of the structural design of Tūranga is the dual seismic resisting system. So it's primarily consisting of integrated self-centering mechanism in the form of hybrid concrete shear walls. They can rock to isolate the building from peak accelerations, and they work in conjunction with perimeter steel moment resisting frames which have rocking base connections. Each rocking shear wall has high tensile post-tension steel cables that clamp the wall to the foundations, each with 1,000 tonnes of force per wall. And the controlled self-centering rocking is ensured by both the post-tension cables but also seismic energy absorbing devices, which are called high force to volume lead dampers, or HF2V dampers. So they're attached to the base of the walls. And then there's also steel U-shaped flexural plates, UFPs, which are shown in that central photo there. And they're at each end of the walls. So the term hybrid reflects that each rocking wall has a combination of hysteretic damping from the UFPs, debonded mild steel reinforcing starters at the base, and also the total system recentering force provided by the post tensioning located centrally. And they have sufficient force to restore the walls and the perimeter frames to their original position after a 1 in 1,000 year return period earthquake. So the combination of the dual system and the replaceable energy absorbing devices and the self-centering mechanism of the building provides a seismically resilient structure. So they're state-of-the-art systems which have been pioneered in New Zealand, and this involved a lot of collaboration with the University of Canterbury. The hybrid walls are arranged into 3 main cores, and they provide approximately 75% of the seismic resisting system, and then the moment resisting frame provides the other 25%. And the walls were located such that the centre of strength, damping and restoring forces were all closely correlated to the centre of mass. And they were cast on site full height. So some of the panels weighed almost 150 tonnes. So they're amongst the biggest precast tilt panels ever constructed in the world. And it was a good health and safety result because it allowed the structure to be self-braced from an early stage in construction. So in conclusion, I hope I've provided a bit of a snapshot of the complex and painstaking work that has been undertaken in Christchurch over the last decade. I've showcased a number of community projects that I've worked on to help try and bring people back into the city, and indicated some of the modern low damage seismic technologies that have been utilised.